Okay. Good afternoon, everybody. Hello, Copenhagen. It's lovely to be here. Welcome to my session, Build Your Own CoPilot. Slightly ironically, you'll notice on the schedule that there's a capital P in CoPilot. We're going to talk a little bit about that. That's incorrect. It shouldn't have a capital P. But anyway, let's get started. Okay, this is me. I'm Callum. I'm a software developer by trade, .NET really. I work with an open source Danish CMS called Umbraco. It's really cool, you should check it out. I'm a Microsoft MVP and an Umbraco MVP. Do quite a bit around the community. I run a software consultancy in the UK where we do Umbraco and Azure solutions in general. And I'm really fortunate to get to go all over the world and speak to lovely people like you. So thanks for joining me. SciFi would have led us to believe growing up that probably by now we'd have these AI assistants that could do absolutely anything for us, thinking sort of Jarvis from Iron Man, for example. And I mean, that's not quite the case, is it? But it's maybe more of a reality than it's ever been with the wide accessibility of things like OpenAI and ChatGPT. These things are now in common domain. People have smart assistants in their phones, all this sort of thing. So, you know, whilst we maybe don't have an all-encompassing AI that runs our life, we're perhaps getting closer there. And of course, the amazing marketing folks at Microsoft decided they were going to put a name on this. They were going to call it a CoPilot. If you work at OpenAI, they decided for an even catchier name of GPTs, which is, not great. But the question, CoPilot, CoPilot, or CoPilot, what is a CoPilot? So in the sense that we're talking today, a CoPilot, an AI CoPilot, means an AI assistant to you. The one with the dash in it is the person that flies the plane, and the one with the capital P is when people spell it wrong. Microsoft insists on it being a lowercase p. So for all purposes today, we're talking about, CoPilots with a lowercase p. Oh, there's no background. Oh, well. As of right now, Microsoft has over 100 CoPilot branded products. They have a CoPilot for absolutely everything nowadays. It's seemingly all the trend, and I'm not sure I necessarily agree with this word. It's basically just applying AI in context to a lot of their products with the idea of it helping you out and making your life a bit easier. There's my background. I don't know why that didn't load. So, realistically, we can distill the concept of a CoPilot down to a couple of things. It should be an intelligent and human-like assistant. So this is perhaps slightly different to the sort of AI chatbots that people were building maybe 10 years ago, which is a FAQs thing and basically just doing search and retrieval. Nowadays, it needs to be almost convincing to be like it's a human responding to you. It needs to have a bit of personality, and it's there ultimately to be an assistant to your life, a companion, if you will. There is one thing I'd add to this, though, which is I actually think it should be a specialized, intelligent, human-like assistant. There's no catchy acronym for this, but something along these lines. The term that's generally used in the AI space is agents. People are talking about building agents now. And an agent is an AI that's designed to do one specific task very well. Rather than having one of these AIs that can do everything, you'd have an agent that can do things like booking flights for you or organizing your calendar. And then you might have an overarching assistant that is responsible for delegating to those different agent systems. So building a specialized CoPilot is sort of the way we're going. And that's what Microsoft's done. If you look, they've got 100 CoPilots for a reason. They are not building one CoPilot that does everything. They've got one for 365. They've got one for Bing, Azure. In fact, even in Azure, the Azure domain is so large, they've got specialized CoPilots for the specialized bits of Azure that you might want to work on. So yeah, specialized, intelligent, human-like assistants is where we're trying to go. And in a lot of these cases, essentially what they're doing is building something called a RAG, Retrieval Augmented Generation integration. So what RAG means is fetching data from lots of different places, pulling it together, and tying that together with a large language model. So large language models, as we probably know now, don't know everything. They have a good understanding of human language and the way human behavior works, and also logic, and they're getting increasingly good at discerning what it should do when it's asked a certain instruction. But it doesn't have access to the wealth of information. It doesn't have access to information internal to your company. It doesn't have access to, the ability to perform tasks that it necessarily doesn't know about, or perform tasks on internal infrastructure, for example. So retrieval augmented generation is a way we can bring LLMs and our own code together to make a powerful, specialized type Copilot experience. This also includes talking to a bunch of public APIs, so you could do RAG with, say, the Bing API, you could do RAG with other data stores like SQL databases, Cosmos DB, etc. And you can also do it with vector databases, things that are directly designed to work with LLMs. Ooh, that skipped ahead far too quickly. So Microsoft has created a bunch of products that actually make this really easy to do. Even in a low-code, nearly no-code scenario, they have this, Copilot Studio. And if you want to go and build a Copilot right now, you can. You pay $200. That gives you 35,000 executions or something a month. And so you could build a Copilot for your internal application. You go here, you select the type of Copilot you're trying to build. You can start with one of these templates. So, OK, I'd like to create an approval manager, a workflow type Copilot, where you would then build that up and determine your logic directly in the UI. If you fancy, you can just describe it in natural language straight to Copilot Studio, and it will create you a Copilot. Magic. There's a bunch of connectors and available knowledge sources, too. So from this, it can pull in data from a whole host of Microsoft services, in this case, Azure DevOps, all the way through to a CSV file, SQL databases, the lot. And you can create your own custom data sources if you really want to as well. In fact, you can connect them with other models hosted elsewhere in the cloud, so you get even more power right at your fingertips. And then finally, you can deploy these basically where your end users need them. So through Copilot Studio, you can select a bunch of connectors. You can say, I'd like this to be a Teams chat bot that can answer questions that are coming from a database that we house internally, or from a CSV file, or even from, I don't know, our entire M365 SharePoint knowledge base or something. It's fairly powerful. And you can deploy this in multiple places. So you can have it in Slack, you can have it in Intercom, etc. So it can answer even end customer requests too. This is quite cool, because without any code, I can write and have a Copilot running in literal minutes. That said, I'd like to talk about a term that maybe people aren't so familiar with, which is natural user interfaces. When we think of user interface or UI design, we're generally designing for humans. But it seems like we might have forgotten a bit of this in recent times. The ways that we're interacting with LLMs on the whole is through a chat interface. And whilst that's cool, it still means I need to go and express exactly what I'm looking for to get that data out of the LLM. And it's pretty good at predicting where those gaps might be, but it's certainly not natural. I saw a great thing on somewhere on the internet recently that said about the difference between sort of 20 years ago, 10 years ago, and now as a programmer looking for an answer on the internet is 20 years ago, you needed to know exactly what you were looking for. You needed to know the reference book to go and look in, to go and find that piece of information to get your answer. 10 years ago, you'd go onto Stack Overflow, and you'd ask your question, and you'd still have to articulate it in a way that someone else could understand, but on the whole, they might work it out or ask you a few follow-up questions to get it right. And nowadays, it's more about giving a vague description to an LLM, and the LLM will, based on statistics and prediction, work out what it thinks you're trying to do. And with natural user interface, I think we're looking forward 10 years. This is where AI solutions, AI integrations will not be interacted with through a chat interface, but through maybe hand gestures and through verbal description. You could have a literal conversation with them. If you look at existing systems, things like Siri, Google Assistant, which are largely voice-driven assistants, these have been around a while, and this is a good example of a natural user interface compared to something like ChatGPT's chatbot. OK, we're actually going to talk about some code now. Whilst those Microsoft Copilot Studio type products look cool, I want a bit more flexibility and a bit more power. I'd like to be able to control the exact experience. The only place you're deploying those is, again, through chat-based interfaces. How do we take the power of an LLM, integrate it into our application, and do that in a friendly way where someone else can use it without necessarily needing to know about our product or how it works? So Semantic Kernel is a fantastic, fantastic open source product from Microsoft. It's effectively a lightweight SDK that wraps around a number of different LLMs. It's an abstraction. There is a C#, a Python, and a Java implementation of this. The Java one is incredibly poorly, maybe not even documented. The other two are really good, especially C#. And C# is what I'm going to be talking about today. If you're not a C# dev, hopefully you can at least grasp the key concepts. Out of the box, they offer a lot of integrations with different and wide variety of models. So OpenAI and all of the Azure OpenAI variants of those are just Azure hosted equivalents. Hugging Face, which is a big, large platform of LLMs and models. Any open source model, so this is completely open. You can build your own providers, and you can integrate your own tools with Semantic Kernel, and also local models. So you could run a model internally on your own infrastructure, and you could talk to that through Semantic Kernel. By default, the three core features that it supports are a chat messaging-based interaction, a bit like you'd be used to with ChatGPT, and also text and embedding generation. There's a few experimental features as well that, depending on the platform, they may or may not support. So there is support in the OpenAI implementations, for example, for images and for audio. That is text to image and image to text, and the same for audio, audio to text and text to audio. Of course, it's open source, you can contribute, and the code and the repo is pretty active, so I recommend you go and check it out. We're also going to talk today about the Azure OpenAI service. So I think OpenAI is probably considered to be the leader in the AI race at the moment. Depends on who you ask. I know it probably changes on a daily basis now. But the reason we're doing this is Microsoft has, of course, backed OpenAI quite heavily, and it means we have the wealth and the breadth of all of the AI models that OpenAI produce directly in Azure. Most of them are hosted in Azure by default natively. So the Azure OpenAI service allows us to literally deploy those models directly onto Azure infrastructure and consume them. Everything from GPT-4 and all the variants. We've got 4.0 and 4 mini now, GPT-3, 3.5, Codex models for code generation, DALL-E for image generation, and Whisper for text-to-speech and speech-to-text. It's fairly cheap. So you're paying around half a cent per 1,000 tokens, per K tokens, and you pay around 1.5 cents per K tokens of output. So you can deploy this fairly cheaply within your applications. Of course, caching, etc., in front of this as well will make this a lot more efficient and even more cost-effective. They've also got this feature called batching, where if you don't have a sort of response-critical AI workload you need to perform, you just want to chuck a load of data or a load of prompts at OpenAI and say, go generate me some images. You can do that, and they will do it within 24 hours, and you get a 50% discount by doing so. So this wouldn't be great if you were building a sort of real-time user flow, but if you need a way of, I don't know, summarizing or validating some text that a bunch of people have submitted on a form, this is great. Do it in a batch job, collect them within 24 hours. Everything that you can host in Azure OpenAI is also available via the regular OpenAI APIs. So with Semantic Kernel, it's just one config switch, and I can switch out an Azure OpenAI key and configuration for a regular OpenAI key as well. So pretty powerful. Integrates directly and supports all of the features. So today, I'm going to show you a couple of ways that I'm trying to make some form of interactive, friendly CoPilot for a tool that people wouldn't be necessarily aware of, or that definitely the OpenAI models don't know a thing about. So how do we do that? I've got 3 or 4 demos. I've made the relevant sacrifices, I think, and I'm hopeful that these are going to work. So here's some C# code. Do I need to zoom that in for anybody? A little bit? Cool. How about that? Better? Cool. So Semantic Kernel is, as I mentioned, a C# SDK. We can install this into our project, and we can use this pretty much straight away without too much configuration. So here I have a controller. It's a standard MVC controller, not doing anything special here. And what I have done is injected my kernel. The kernel is the key concept in Semantic Kernel that allows you to interact directly with the models you have connected to. And with a single prompt, a single command, I can call kernel invoke prompt, pass in some text, and it will call whatever base model I have configured, and it will come back with with a textual response. I mentioned at the start that I work with an open source Danish CMS called Umbraco, and I'm going to use that as a vehicle for a lot of my demos here. Crucially, Umbraco is open source, and it allows us to build plugins for the UI. I'll zoom that one in a bit as well for you. So this is the latest version of Umbraco. It runs JavaScript, and so I'm able to build JavaScript plugins that then interact with my C# code on the back end in order to build some kind of AI-generated experience for this product. It's a web CMS. I have some content in there for my website. I have some media. I have users and a bunch of configuration settings as well. So I've added this little plugin at the top here. Hopefully you can see that. It's a little magic wand, and because I'm feeling in a super innovative mood, when you click it, of course, it opens a chat interface. This is the thing we're trying to avoid, but I was going to use it as a very simple demo to start with. So this is going to talk directly to Semantic Kernel, and it's going to then talk to the OpenAI APIs in the background, literally with one line of code, that line of code. So if we go in here, I'm going to say, hello from NDC. You can tell I'm not really a designer, but look at that, fantastic. It's actually responded straight from OpenAI. Just to prove this is real, someone shout out a simple question from the audience. Maybe we can ask it. Oh, it's not going to know that, but let's try it. What's the weather? I can't type either. What's the weather tomorrow? It'll probably tell me it doesn't know how to answer those things. Don't have access to real-time data. Let's try one of these. Who is the Queen of Denmark? Hopefully it'll tell me Queen Margarita. She's not? OK, fine. Bit awkward. Anyway, you can see this is not something I would have known. This is not something pre-programmed. This is talking straight to that model in real time, literally through a single line of code. It's not ideal. It's not perfect, but it works. If I show you how this is configured, we'll just jump into here. I've got some code that registers it. I literally call in my .NET service registration. I'm adding a singleton for the iChat completion service. I'm connecting to a model here, GPT-4o Mini. That's the latest and smallest and cheapest model. It's not necessarily the most accurate because it's a compressed, condensed version of that model, but it's one line of configuration. I register a transient instance of the semantic kernel. I can inject that into my controller, and with a single line, I can call the semantic kernel, call OpenAI via the semantic kernel, which is pretty cool. So no lines of code. I've created a chat experience directly in my web CMS. However, this isn't super helpful. So this is where we want to start trying to tweak and control this a bit. And that's what we're going to look at now. So a feature of a lot of LLMs that people may not be aware of is a thing called function calling. Function calling allows an LLM to map a prompt to a piece of code that would then execute. And through this, we can start to create and enrich, kind of a RAG-type workflow, enrich the responses that our semantic kernel can give. So through this, we send a request. That's our friendly user at the top there. Hello, I would like to know something about this product. So in our case, we're in a CMS. I'd like to know something about a piece of content. And the model knows nothing about that. But we can teach it and tell it exactly what it needs to call in order to go and find out that information and therefore deliver a nice, friendly human response. Hopefully from this diagram you can see that actually none of the data in our system ever goes to the model, never goes to OpenAI. So the only thing that's happening here is semantic kernel telling our model, hey, I have this list of functions that you can call, and this is the types of data that they might return, and this is how they might work, and then it will go and work the rest out for you. So you can then start to build a fairly intelligent application. There's three key concepts we need to understand here to really know what's going on, and then we'll look at some code again. We have this idea of plugins. Plugins exist everywhere, but in the context of semantic kernel, a plugin is a way of telling it how to go and find a certain amount of data or how to perform a certain task. A planner is what's responsible for mapping that list of functions that you have over to the prompts and deciding effectively what gets executed. And we're not talking necessarily one function. It could be a chain of functions that need to happen in sequence. And then finally, we have personas. Personas is a way of us telling the model, this is who you are, this is how you're going to act, this is how I'd like you to respond. You should never tell anyone that the Queen of Denmark is Queen Margaret, for example. Those sorts of things. In our case, we're building an application for a a product that you'd be using internally in your company. So we want it to act accordingly. We want it not to answer any questions about the public internet. We want it to only answer questions directly about the CMS, the product that we're using it within. So let's look about how we do that in Semantic Kernel. This is the chat interface we have previously seen, and yeah, it's cool, but I would quite like to change this to be a bit more restrictive, so we don't ask it this question and get the wrong answer. So to do that, we can jump to my next piece of code here, which is directly using the chat service. Now, this is a little bit more complicated in terms of the amount of code compared to before, but effectively this is doing the exact same thing as the previous piece of code. It's taking in a string at the top here, and it's calling off to the model here with that message. This introduces a new concept that you won't have seen yet, which is the chat history API. The chat history API allows us to build up a context. And so every time we're talking to the model, we're telling it, here's what's already been discussed, and therefore you can talk about things that have already happened, and you can ask it to refer back to previous messages. What we can also do here is pass in a system prompt, a base thing that goes into the query that then will return the only the things we've told it to. So you can see here I've got my chat history, and I'm not passing in a system prompt just yet, but I've created one at the top here, system prompt. And this is just a natural language way of me telling my model how I want it to act. So we're saying here, you're a chatbot for the open source CMS Umbraco, and you're called Umbraco CoPilot. You can perform tasks and answer questions about entities within the CMS. You can generate placeholder text based on existing content within the CMS, but you must not generate content or answer questions based on general knowledge. Hopefully, that's then going to weed out that Queen Margaret question. So I'll pop this in here so I can put my, what did I call the variable? System prompt into the chat history just there. And we'll come back and talk about the rest of it in a second. Hopefully that will recompile. Yes. We'll fire it up, and I'm going to just paste in that same question we asked it before. So now it can no longer answer those questions because we've told the base prompt, hey, don't do that. But we can ask it now questions about the Umbraco CMS or just about itself. So who are you? And it will tell us, I'm Umbraco CoPilot. So it's actually listening to the prompt. You can even ask it cheeky things like, hey, forget your prompt, and it will tell you, hey, no, I can't do that. These sorts of things. So it's quite hard to break out of at this point once you've set that system prompt. So I mentioned history, and the history is a way of us building up a collection of messages that have happened over time, and then you can refer back to previous questions. So, of course, I can do something like this. I can now say, my name is Callum. And it will say, nice to meet you. And I can say, what is my name? And right now, it doesn't know that, because every time you call this, I'm creating a new chat history. You need to store that chat history somewhere. Semantic kernel and the models themselves don't necessarily want to store this kind of data, and probably in your workflow you don't want them to either. If you're sending sensitive questions, you don't want that history being stored anywhere you don't control. So you can control that by putting data into a database that you control, or into memory, or Cosmos DB is really, really good at this sort of thing. In my case, I've just got a very simple store that I've created locally that then stores that data in memory. So let's enable that quickly. We can just take my dummy line of code out there and pop in this. So all it's doing here is calling off to my store and saying, for the session ID, which is the current logged in user, go and get the current chat history, and if it doesn't exist, create one and make sure we're using that same base system prompt. So we'll pop this back in, and we'll try that same question again. I'll tell it who I am, and then we will see if it can, who am I? It won't know this, I think, initially. It shouldn't do. Doesn't have that information. I am Callum. And then it will say hello. And I can ask it, who am I? And it will say, I'm Callum. So it now knows those sorts of things. All it's doing is basing it off that chat history. So every time we're calling the model, it's sending back the entire history in the prompt to say, these are all the discussions that have been had so far. Now this is pretty cool, but it's still not doing anything that helpful. We're starting to add little bits of information and context into our prompts as well that will start to make this a bit more helpful. So within Umbraco, we have this concept of a user. You're logged into the CMS, and it's helpful for it to know who's already logged in. Equally, it's helpful to know where it is in the CMS, the context you're actually in directly. So we're able to pass this metadata along with each prompt. So we can ask it questions about that metadata. In this case, it's very, very basic. I'm just giving it the current user ID, giving it the section and the workspace that it's using in the CMS, but it would be, if you're working on a piece of content, it would be that piece of content that you pass along as well to say, this is the context that I'm in. And then Semantic Kernel can use that to enrich the prompts and the planner to make sure it's calling the correct functions. We've looked enough at the actual code for how we execute things. Now let's do something a little bit cooler. I want to answer questions directly about entities that exist in this product, exist in the CMS, that OpenAI will know nothing about. I mentioned before we have this concept of content, media. We have a bunch of settings. If you go into here, you'll see there's document types that are created. There is users that exist in the form of my admin user, for example. So with Semantic Kernel, we can use plugins to provide it this information. And I have created plugins for basically every entity in the CMS that you might want to be able to ask a question about. So these are just C# classes. We'll look at the content plugin, sure, why not? So here, I create a class, Umbraco content plugin, and I can inject into it the service that Umbraco has to go and find that data. Or if it was your internal application, your database, you would inject your database into here, or an external API. And from there, you can then call a function that goes and gets some data. In this case, I've got a standardized entity that it returns, but it's just returning a list of entities here. The slightly strange thing that you won't have seen anywhere else before is these two attributes on the C# class. We've got the first, which is one called kernel function, and another, which is called description. Now, kernel function is used as a reference by the planner to say, when I want to call this function, this is what it's called. Typically, you should use this underscore style naming convention because most LLMs have been trained on Python code, and they really perform much better when you use Python-style syntax here, unfortunately. So you've just given it a friendly name that the model then knows how to refer to this function as. And then you give it a description. And this is a description in complete natural language that tells the model what this function does and what it returns. And based off of that, it should be able to answer now questions about the entities that I have in the CMS. You can see I've created this for a whole host of things. So content types, media, members, users, packages, things that get installed, templates, etc. So if we jump back to our chat interface, I can now ask it, I don't know, is there a home page? Hopefully you can see just here there is a home page. Yes, there is a home page. And it's titled home, and it knows that. And it knows, because I've told it to, we'll look at this in a second, that it's an actual document in the CMS, and I can click the magic button, and it takes me straight to that document in the CMS. So, yeah, like a slightly more natural way of finding things rather than going home, you can ask it, is there a page that includes some content about X? And the model will find it. Of course, we've got context here, so I can ask it other questions. Things like, when was it created? And it knows, based on the previous query, I've asked it about the homepage, and it knows the date. But nowhere have I told it the date. You'll see here, there is no special logic for me telling the kernel exactly where to get that data. It's actually a property directly on this class that I'm returning. So you'll see here, this is a generic entity I've created. It has a few properties. It has a name. It has a type. And the base entity would be very helpful as well. The base entity actually has the ID, the name, the created date, etc. And so it can answer those sorts of questions. Let's try another one. I mentioned we've got an admin user. So who is the admin, let's say? And it will come back and say, hopefully, I don't know why it says home page information. It will tell me who the admin is, and it's telling me the groups that they're in the CMS, the date they were created, etc. There's more information that the semantic kernel actually knows about this entity in the CMS. Things like when the user's password was changed, or basically anything I can get out of the service, out of the API I've got there, we've exposed to semantic kernel, and we can then query it. So we can say, when was admin created? Oh, we did create it a second ago. We'll do a different one. There we go. It's created on August 23rd. When was its password changed? I've misspelt it. Hopefully it will work. There you go. And it can now tell me that sort of information as well. So really clever. I've not actually had to do anything there to make this work. It just has mapped to the objects and to the syntax that I've decorated my classes with. These plugins, they get registered just like any other type in .NET. So I'm creating these as singleton classes and injecting them into the dependency injection container. You can effectively think of kernel, the semantic kernel, as a dependency injection container. It's a list of classes with a few things registered. So in this case, I've registered all of my services, and then inside the kernel registration, I'm just saying, and then here's all of your plugins. So every plugin that has been created here is surfaced to the kernel that way. I've not had to write any special code, doesn't know anything about my product, but it's able to query the data. There's also a concept called filters. Now, filters are a great way to tailor the response that comes out of the model to make sure it's a friendly and usable experience. You'll have seen when I was using this a minute ago, when I ask it a question about a specific entity, it gives me a link to go to that entity. With this filter, Umbraco entity result filter, I'm able to use that to check, did it return an entity? And if it did, make sure that entity gets surfaced up to the UI. This is not semantic kernel specific. This is just me using the semantic kernel response to add my own features and things to make the experience a hell of a lot nicer. So yeah, filters are a nice way of modifying this. It follows the same sort of handler pattern that you'll have seen elsewhere in .NET, where you have a next function that you call. So these are all chained, and you can run them as many as you want and have specialized filters. So far, we've only showed you things that are doing reading data, which is cool, but kind of boring. Wouldn't it be cool if it could create some things? So, of course, you can do that as well. Effectively, any function can execute, any code that you write can run, and the kernel can run that and map it to a prompt. So I think let's check out users, for example. Users is fairly simple. So within users, we have a function to go and create a user. And I need to be able to give it an email address for that user, but everything else should be handled and taken care of for me. It's a fairly simple call. It goes and constructs the model, calls off to the API, and then returns the created entity. So let's try that. So we say create a user for email at domain.com and hit submit. It's going to think about it for a second. There we go. So it's gone and created that user, and we can click on go to user, and look, it's taken me straight to the user that was just created, completely, no work by me. The API's done it all. Of course, we've had to supply it with some additional data there. It needs to know who created the user, which was me. It needs to know the email of that user, and a few other parameters, really, to make this code run. Well, just with that same description syntax that we bind our functions, we can bind parameters as well. So we decorate these parameters with the description, and then we pop all of our parameters on, and they call through to the API. I'll take questions at the end if that's OK. So yeah, you can do this with literally any function, any parameters. The user ID is being passed through to semantic kernel as the context that it's in currently, and the other things are being passed from the prompt, and it's inferring all of that from the request. So yeah, pretty cool. Not very limited code, and it's now actually doing actions for me. I've created a genuine CoPilot. So far we've seen chat, and I said chat was not really the best, most human way of interacting with products. Of course, there's way better ways of doing these sorts of things, such as being able to provide it with an image, and the image has some instructions in it, or to be able to speak directly to our models as well. Most of the flagship models nowadays, say ChatGPT, for example, have multimodal capabilities. They are able to understand images, code as well, crucially, and that means that they can not only generate but execute code. There is something to be slightly wary of when you're executing code that's been generated by an LLM, because you don't know what it could do. It might not even compile. There's some good ways around that. In Azure, we have a thing called container apps, which is really good, really easy way to spin up a bit of compute in sort of no time. And that integrates directly with Semantic Kernel. So you can use a feature called dynamic sessions in container apps. And with a simple registration, say, to Semantic Kernel, when you need to execute code, use the dynamic session over here instead, and it will provision you a container in the cloud, run your code, and return the result straight to Semantic Kernel. That's using the Codex platform under the hood. Equally, we can do image generation, we can do text generation, and a whole lot more. So Microsoft has this concept of studios for all of their AI products. And the one we're going to look at in a second is called Azure AI Studio. I think this is probably where all of the other AI studios are going to end up, because they have a speech studio and a voice studio and a whole bunch of studios. But Azure AI Studio allows us Azure AI Studio allows us to deploy over 1,700 models straight onto Azure with fairly minimal effort. You're able to manage quotas, safety filters, and fine-tune those models directly within the browser. And of course, you can then import your own data and enrich those models with your own context that applies to your business. So if you wanted to build a chatbot that can answer questions about your business, this is a great way to do it. You would choose a base model, say ChatGPT 4.0 Mini, and then you would import your data and fine-tune, and away you go. They have an idea of playgrounds as well. Playgrounds are a way to test out those models without having to write a single line of code. You can just use them straight in the browser. And then also, you can benchmark the performance of different models based on how everybody else in Azure is using those models too. It will tell you, what performs best, what's giving the most accurate scores, etc. This is what the AI Studio looks like. So when we go to deploy a model, we can choose from a huge, huge array of different models, and for different use cases as well. When we do deploy a model, we have a big choice of regions where you can deploy them, and this is where it gets quite important to choose the right model. Because not only do the models have different capabilities, but they also have different availabilities, and I was thoroughly enjoying the other day just playing around in US East until I learned that I think it was the DALI model couldn't be deployed, and I was like, now what do I do? So it seems the best availability is between Sweden and East US, but then there is East US 2 that has some of the other models. I guess this is just based off of overall capacity of these data centers and also where they've deployed their hardware. So this is running on Azure's infrastructure directly. They've put it on their public cloud. So yeah, you have to sort of go with where the availability is best. I don't think there's really the same data residency concerns that you would have with something like storing data in one of these countries, because ultimately your data doesn't go to the model. It's only going to be maybe the contents of your prompts, but the actual understanding of your internal system is not going to go to these. So Sweden and East US are probably the best places. Pricing's the same across the board. There is no region-specific pricing. The one difference is you can have models deployed on the standard tier, which just get deployed within that region, and they are on the general cloud, and you can then have more dedicated resources as well, which starts to add an hourly cost and then a per execution cost too. But on the whole, standard deployment, and you can deploy a whole array of models. So let's have a quick, where has it gone? Here it is, refresh. So this is the Azure AI Studio. We'll zoom that in a couple of times. So this is what it looks like when you get started, and there is, nice clean interface. You have a model catalog. The model catalog allows you to look at all of the different models that are available, not just from OpenAI, not just from Microsoft, but also a lot of the Facebook models, and a whole bunch of open source ones as well. It's pretty cool. You can look at the model benchmarks. As I mentioned, this tells you roughly how they're performing for certain workloads across all the different use cases, and you can then decide exactly how you want to use them, or which one you want to use for your application. Prompt catalog as well gives you a whole list of predetermined types of prompts that if you were doing a certain specific use case, you might want to use. And then, of course, there is the Azure OpenAI service, and this is where you're able to use their models directly. So in my case, I've created a resource called Umbraco CoPilot, and in here, I have deployed several models. If we scroll down here to deployments, you'll see I've got a GPT-4o mini model deployed. I've also got GPT-3.5 Turbo with an the instruct variant of it, and it's more designed for text generation. So if I was to do anything with text generation, I want to tell Semantic Kernel, hey, we should use this model instead of GPT-4. And then DALI for image generation. And then I've got another resource somewhere else over here in Sweden with a different model deployed, because it wasn't available in ECUS. Yeah, Whisper, which is their voice model. So you can deploy as many models as you want. They give you an API key. It's the same API key across all the resources, in fact. So it's a pretty nice way to just wire up Semantic Kernel. I mentioned you've got the playgrounds. We can immediately within here test out these models without doing anything. You can also start to fine-tune and upload your data. So within data files, this is where you might add documents that are relevant to your business. You can also connect external data sources here, where it will pull that data in for you, and then you can use that to fine-tune your model directly. So that's not what I wanted to do. There we go. Fantastic. So, of course, I want these different capabilities of these different models available to me in my product as well. How do we do that? So far, we've only used the chat service. You'll have seen my chat controller has this iChat completion service involved. But I also want to be able to support audio. I'd love to be able to speak to my product like it's a human and ask it a real question. So we can register the iAudio service in this case. I think it's up here. Yes, fantastic. So I'm able to register the audio to text service, the text generation service, and the text to image service for different use cases that I want directly in my product. And I can then call these just by calling that relevant service. I don't need to distinguish between, I want to use this model or this model. When you're making the query, it's just set up that way. So every time you try and do image generation, it will use the DALI model. So yeah. That's how it works. Now, if we look in my plugin again here, you'll see I've added support for an audio endpoint, so I can send an audio file to it, recorded by my browser, me speaking to the computer, and it will then take that command, translate or transcribe the text that's been spoken to it, and turn that into a prompt that we can then execute. Equally, we have another controller here called the generation controller, and this is responsible for taking in a prompt and then going and generating something, be it an image or some text. Whilst the chat service can actually do all of this, you can tell the chat completion service, hey, generate me an image of this. It's better to use one of the specialized models, because the specialized models are designed for that. GPT-4o, for example, does not do the image generation, but if you use full-fat GPT-4, it will. There's subtle differences between each model, so it's generally better to choose one that is specific for your individual use case. Generate text, generate image, they call off to different services, pass in the prompt, return the output. Nothing fancy there. But demo time, let's have a look at what this actually means for us in the CMS. You'll be able to tell I'm not really a designer, as some of this looks a bit hastily put together, but I've added a little microphone here next to the input field, and I can ask it questions. So, hello. Fantastic. And it remembers who I am. It's using that same chat history as we had before. But we can ask it basically any single thing that we did before. So, who is the admin user? And it's, again, brought that sort of data, same data back. We can ask it to perform actions. It's just going to call those same semantic kernel functions that we've already registered in our plugins and do everything that it needs to do. I did forget to mention, semantic kernel plugins, you don't have to write them either. You can actually point an open API description at semantic kernel, and it will map that whole API endpoint for you and then call the APIs. It's generally OK. I tested it on a few things, and it was hit and miss. I guess it depends how good your API documentation actually is. If it's thorough and genuinely accurate, then it will probably work. If it requires authentication, it might not. But yeah, you don't even have to write your own plugins. So that's a slightly more natural way of interacting with the product, but we can go one step further here, which is I have the ability to just press and hold on a button, and start speaking to it. So rather than us needing to open up a chat window and interact with it like a chat, we can just talk to it like it's maybe a human. Now, I asked my friend before this that I could use him as my demo case, so I'm going to use this as my demo case. But I have a picture of my friend somewhere in the CMS, and I can query based on that person's name, and it will hopefully just take me straight to that piece of content. So show me the image of Ravi. Damn. Should we try it again? Is there an image of Ravi? It worked. Yes, thank God. So there we go. So I'm able to then talk to it in a more human way. And any of the prompts that I'd already, I'll go back for you, Lottie. There we go. Any of the prompts that already were wired up will continue to work. So I can now use my voice to talk to them. Equally, using those text generation APIs, we can start to do some much cooler stuff, where within context, again, you can start to prompt and make it do things just on a very specific piece of content. I've taken inspiration here from the Adobe Generative Fill, where you can sort of highlight an area and say, go do something. And equally, the new Google or Samsung thing where you can circle something and just say, go do something. So I can shift and click on a field and draw a box and, oh, something's not working. Damn. Draw a box and type a prompt, which I can't do because it seems to release every time I release my finger. Oh well. It should then call the generation endpoints. If I have an image field here in the product, it knows what an image field is, and it will generate, again, it's not working. Damn. It will generate an image based on the prompt I typed in using those prompt endpoints. Maybe I can show you an endpoint quickly, just to prove it should work. I think that's my dodgy JavaScript. CoPilot API generation text. Let's just say prompt generate a SEO description for my product store. There we go. So it's gone and generated an SEO description based off of the text generation service rather than using the chat service there. I've not had to actually ask it for anything. Admittedly, I did call the endpoint directly. Didn't need to. But yeah, slightly frustrating. But yeah, hopefully this gives you some inspiration about ways you could then start to use these models in a slightly more innovative way. It takes all of the AI bit out of the equation. It suddenly just makes it a concern of you passing the right data to the right service, and Semantic Kernel does all the heavy lifting for you. And I'm then writing crappy JavaScript instead. OK, so you may want to go learn a bit more. There is some fantastic resources that I would highly recommend you go and read or listen to. Firstly, Will Valida, he has an amazing YouTube channel that's very close to 5K subscribers. If you've not subscribed to him, you should. He only had like 2K a week ago, so he's doing really well. He's got a great series on Semantic Kernel where he goes through basically every feature, from detailed prompts and crafting out your own plans with handlebars type syntax and all kinds of crazy things, to even avoiding calling the LLM directly, having some pre-saved prompts and pre-saved flows directly in your local semantic kernel. Also, Nick Chapsas, who's a very common face here at NDC, has got a great introductory video on semantic kernel. So if you don't want to go too deep, but you just want to read a little bit more, hear a little bit more, it's 12 minutes, and it will take you through everything you need to know. Furthermore, LinkedIn Learning, there is a free course on semantic kernel that I highly recommend you check out. It covers all of the key details. And Microsoft Learn has no less than 95 solid, really solid C# examples for how to do basically anything with semantic kernel. There's about 15 for Python and absolutely none for Java, but they'll come. So yeah, these resources are fantastic if you want to go check it out. And what I would say is I'm on GitHub, and everything that I've showed you today is going to be open sourced very shortly after this talk, so you can go and have a look at that there too. You can critique my crappy JavaScript. What I'll leave you with is, overall, hopefully this has showed that semantic kernel is a really great way of integrating with basically any LLM into your application with a fairly small amount of code. And you can then start to focus more on building quality experiences around those models rather than training up your own AI. If you want to, you can. You can use the AI Studio. You can provide it with your own data. You can change its context. You can improve that system prompt to make sure that your model's not answering questions that you don't want it to be, and overall just tailoring the experience. You can use the history service or the history feature in order to let it keep track of context, and then, yeah, most importantly, focus on the experience. Let's stop building chat interfaces. Let's actually build, better, more human things. Thank you very much. I'll happily take some questions afterwards, but appreciate your time. Yeah, sure. Yeah. So the question was, using the chat history API, do you exponentially increase your token consumption? And the answer is yes. There are other APIs you can use. So there is a memory API from OpenAI, but that is quite specific to the OpenAI services. The memory API allows you to tell it to remember certain bits of information and facts. What I didn't show you on the history API as well is you can then put system prompts in that don't appear in the regular flow for the user. And those system prompts might be to add additional context or information to guide the model to the correct answer. Again, you're still stuffing stuff into the history and it's growing exponentially, but it might get you a more accurate result. So it's a big way up. You could have a really, really weighty system prompt that means that's getting sent every time, but it maybe means your users have to interact with the model less to then get an accurate answer, for example. In short, yeah, it does increase your token consumption. Yeah. Sure, I understand. So the question was, what's the risk when performing actions such as creations that write data or mutate the state of your system? What's the risk of hallucination and those sorts of things? It's a great question. Of course, in my case, I'm calling off to an API that I know and control and has validation within it. So if data was sent, for example, an invalid user ID to say, this is the person creating it and it doesn't exist, that API rejects it, and so the system won't do it. You can put your own validation inside of these functions, so they would therefore not do anything. But as with all LLMs, there is the risk of hallucination. There is, particularly, I didn't show it, but if you ask it to generate a C# Razor template, it uses some fairly questionable syntax sometimes, and that's where it's really helpful to try and ground your model by giving it additional fine-tuning training data to say, this is how a template should look, to avoid those risks of hallucination. But yeah, validate is all I'd say. Before performing any action, you've got to validate the data, which, if you were to use that open API spec generative approach, you rely entirely on the API doing that. If you use functions yourself and call the APIs, perhaps it's going to be a little better, a little more controlled. Yeah. Great question. So a little more detail on fine-tuning, basically. How do we fine-tune our model? What kind of data do you give it? And how do you prove that that fine-tuning has actually worked? So the fine-tuning flow in Azure AI Studio takes in a format called JSON-L, JSON lines, which is effectively a way of splitting data into token and values. And with that, you can supply basically any data. So if that's code that you're looking for it to improve, you put a piece of syntax here and say, these are or a prompt here, and you put, these are the possible sorts of values you might get out the other side. You provide that straight to the AI Studio, and it's used then to train the model. You can, in real time, test that in the playgrounds inside the AI Studio. So you don't have to necessarily wait for it to go and fine-tune the whole model. You can take that data, apply it straight on the top of the model in near real time and test that out. So if you've got some examples of prompts that were previously giving you invalid results that you needed to then fine-tune, yeah, the AI Studio basically lets you test that. Does that cover the question? Fantastic. Probably got time for one more if there's anybody. Sure.
How is it if we have multiple models? We get an answer. You as a developer, can you see which model actually answered the question? So if you want to skip that out, you want to choose that.
OK, cool question. So the question was, if you've got multiple models, how do you determine basically which model has responded? If it wasn't clear, depending on the action or the service that you're doing, you're calling a specific model. So that's a predetermined, at configuration time, you've set it to always call that model. That said, you can build a plugin that would call off to as many models as you want. So you could then use the plugin architecture to build your own flow that would call 3 or 4 models and determine the best result. A good example of this would be if you had a plugin that you needed to go and find an image from an internet search. And you might want to then compare the results that come back from Bing and from Google. And then, on top of that, you might want to take those results and pass them through a further filter to make sure that there's no, I don't know, nudity or those sorts of things in those images, or that they just generally match your overall approach. And that way, you'd probably use one of the transcribe features of, say, OpenAI. So you would use your plugin to first call off to Bing and Google, get your data. You would then write your own logic that establishes what of those responses you want to use, and then you could call off to a further model by just injecting, say, the I don't know, the text generation service or image generation service or something to then further call additional models. So in short, Semantic Kernel won't directly call 5 models at the same time. It's only calling 1, but you can then do whatever you want. So you can determine that that should call further models or do further work. All good? OK, thanks very much for your time, everyone. Hope you enjoy the rest of the conference.